All right, we can go ahead and start. All right, so just now we have seen the scale troubleshoot process, right? So which is 128 ports, and we run the BER test, and we find out channel by channel. Now, for day-to-day life, when we install these parts into the data center, so we wanted to develop some quick tool which will go one part at a time and give you the result right away to the operator. The current existing tools are very expensive, like as I mentioned in my previous book. So we had a development which is iQSFP tester, we call it, and which is very cost effective. So along with me, I have Vincent Zeng and Jimmy Leung. I'm sorry, it's my bad.
They always mix me up with
Jimmy Leung, who will go over some mechanical part of this presentation. That's my bad. Okay, so the outline of the presentation. So we will go with some of the problem statements, which will be pretty similar to the previous talk. And this iQSFP tester, we already patented, filed a patent on this topic. And also we will go over the product design concept and the product information, followed by some environmental test, and we'll recap it at the end. So the problem statements, it's like, again, when optics fail in data center, we have no information except it failed the link, right? So that was a big challenge when we started deploying the 1 million kind of number of optics in our data center. So, and the current diagnostic tools, if we use, the expensive tools, like you need like several of those tools because it could be the top of the rack, it could be the fabric, it could be the spine. So we wanted to do a cost-effective and efficient troubleshoot tool, which we will use only to find out the good and bad optics purpose. We don't need any fancy stuff. We don't need any traffic generator, right? So the existing capital equipment does not support millions of transceivers. Like, I think that was one of the questions. So this tool is capable to use in the day-to-day operation and find out the good and bad optics right on the spot. So this is kind of patent disclosure what we filed. It's a very simple tool which is pulling the DOM information where you have all the TX information, RX information, vendor information, and it runs a simple PRBS pattern to find out the BER results. And based on that, we can say, okay, these optics is good, these optics is bad. And also there is another good feature of this is like it goes channel by channel. So you can find out exactly which channel has the problem. Is it channel, because it's a CWDM4 technology, you have 4 different channels. So finding out which channel has the problem is very, very important. So with that, I will pass it to Vincent, who will go over the product design.
Thank you, Abhijit. We have this, the concept is I mentioned that when we have deployed millions of the optics in our data center, the most challenge for the data center is about the operation efficiency. So whenever you have the link-related failures, and then you will take extra times to debug, to isolate whether the failure is coming from transceiver itself, or coming from switch, or coming from the fiber, because it's associated with a couple of 100 meters of the way of the troubleshooting. So we came out on this idea, and then we want to have a portable devices, which is very cost-effective, which almost every operator can have one. And then they can on-site to get the troubleshooting immediately on site. So we can identify whether this issue may coming from the fiber itself or coming from switch itself. So given that background, and then we come with this, the product design. So first of all, you can look at on the bottom of it is like a 3D of the earlier phases of the devices model, which will require like a LED display, which is showing to the operator just the fail passing, this kind of a very fundamental of the information. And also we can have like the BER or this kind of testing because we embedded with the PRBS inside it, so they can generate some certain of the traffic. And then later I'm going to talking about how we define the pass and fail criteria. And also another thing I want to mention here is that if you have been using the transceiver for many switches platform, one thing we noticed that the cage itself, the maximum making time is about 200 times, 250 times. And so in order to through the whole devices after you measure 250 unit, and then you can continue use it with this design, basically use the Dr. Carr's design to just swap the QSFP cage. Okay, and then another thing I want to mention here is about the friendly reporting structure, because every operator or the technician, they tested one unit, they want to understand whether this is a fail or passing, they must have a certain record. That is where we develop it of this structure. So pass and fail criteria, we have 2 steps to define. The transceiver is working in the way that they have like a transmitter send the signals out through the loopback, and we receive it on the receive side, use the same devices. So we are judging the power differences between the receiver and the transmitter side. We can see whether the transmitter's power is below the spec. That is one criteria. We use it. And second one, if that's meets the spec, and we will issue the PRBS, the traffic generator, and into the second defense line. And then during our earlier phases evaluation, we perform a lot of testing based on our prototype samples, and then we perform probably 20 or 30 different suppliers optical module from 40 gig to 100 gig, and then at a different temperature, at a different power budget, and all these kind of things have been testing. And then what we directed to compare with, you see here, is with a real traffic generator, or some cases we measure, we directed with the spectrum analysis, and then to get all the details information to see whether this devices really give us very reliable the data. So this is actually the data we measure the eye diagram on the standard, like the manufacturing testing line, and then we compare with whether this unit give us the good or bad result. So we also develop like a very standard, like the spec, because we want to share this product or this idea to the OCP, and this spec is available from the OCP. And then given that, I want to give the Jimmy, not Jim, Jimmy, and more on the mechanical design.
Thank you, Vincent. Can I see a show of hand that you are a non-engineer in the room? Wow. Okay, great. Thank you. So as you see on the screen right now, there is the iQSFP tester. The reason is we make it a portable device is we need to bring it from the office to the data hall. So in order to allow it to be portable, I mean, basically we just have to design a portable device. And from all this view, you can see most of it has a rubber boot show on the outside. Only the back view doesn't show it. The reason is I want to show you guys, we're using standard industry component like QSFP cages, like Vincent was mentioning. Because those are like between 250 to 300, depends on the quality of the parts from the QSFP cage vendor. So we want to allow end user to be able to replace the cage. Otherwise, you use 300 times and you have to chuck that tester away, which is expensive. And then on the other side is we have rechargeable battery. So if the battery life go down, we can actually replace it. Then you can continue to use the tester for the longest time. So we designed the tester, we shipped it. We also designed the box to protect it for the shipping. So we just don't send the tester by itself. So it's kind of like a extra protection for it. So I'm engineers, a lot of folks are engineers. What engineer likes? They like to build things, right? But at the same time, at the end, they like to break things. So in order to make sure that the product that we design meet the requirement, at the end of the product validation, we do all sorts of testing, environmental testing, drop testing, shock testing. But one of the things I want to point out is water resistant and dust ingress testing. So this device is bringing, like, you can use it from office space all the way to the data hall. So in your office space, what people usually do, they have coffee in the morning. So in case if you don't want your device to get short, you want to have a water-resistant protection. So that's why we tested that with the rubber boots installed. So this is basically the rubber boot itself. So if you feel you don't want to carry the unit with the rubber boot, that's fine. But if you want it to be protected from water, from drop, from dust, please put this on. So I'll give it to Vincent for the summary.
Thank you, Jimmy. The takeaway from this presentation is that what we offer to the OCP community is portable devices that can help us on the on-site debug the QSAP the devices, and it also give us we offer this devices can test it. We estimate is about 150,000 of the devices you can measure it per lifetime of the battery. So given that, I would like to take any questions.
So this device, if I understand it, is to test the QSFP module. So you plug the QSFP module into the device, right?
Yes.
It just basically does like a loop back, right?
Exactly.
I mean, I see a couple of potential issues. One is that in this case, you would be doing this would be synchronous, right? So if you have any kind of clocking issue, it wouldn't deal with any kind of clocking issue because many of the modules where typically you're going to have, like if you have CDR problem would be when you have asynchronous, But in this, I believe the way you run it, this would be only testing synchronous mode. Another potential issue that I see is that many instances, especially with PAM4, where there is issue with the CTLE setting not to be correct, or in some cases, for example, some SerDes, are designed for copper cable. When you plug and you overdrive the input, it could be, there's a lot of those sort of what I call the secondary issue that doesn't take into account, I mean, do you see that this really helped? Because if
So sorry, I think it's a very good question, and let me answer this to our first question regarding this is like the first step for our defense line. So what we can do, we can reading all this transmitter, the healthy versus the RX, the healthy as a first criteria.
Right.
And second one, we can use the PRBS to generate. Then obviously a lot of clock-related issue is not addressing here. So the way that we combine with our beam is going to do in the second work.
Okay. Because one of the suggestions I would would be to have two of these units at least. So at least you have independent clock,
Yes. Actually, that is some of the idea we're going to combine with the PAN capability is the next generation of this product. This is called the revision 1 and then next generation revision 2. So
okay. Thank you. Good work.
Yeah, thank you.
Hi, Vincent. My question is about the record keeping. I guess, when you plug the module in, you read the serial number, you read the, vendor name and so on. Yeah. Do you store that record, and then how do you, upload it to next?
So one devices can record about 3,000 of the devices of all the informations.
And is there a way to upload to the console?
Yes, we do have we just have the GUI to uploading all the files and then generate testing report. Yeah.
Can we take one more question?
Yeah.
So is this ready for users? I mean, is this purchasable now, or do you guys intend to make it?
Yes, we are ready to kick off to the mass production right now for this product.